In our last video, I showed you how to connect an LED to the breadboard and then wire it to Arduino. And now we're ready to program it. So just as a refresher, we've connected the green LED, and from the positive end of the green LED, this green jumper cable, that's being hooked up to pin number 8. So that's going to be really important to remember as we do this. We'll see as we go off and code it, you could actually don't have to do pin number 8. As long as we code whatever pin number that you selected, that's what's important. So let's go off and start our Arduino application, which you should have installed already. And so we're going to load this up. And if this is your first time loading it and creating a first program, I'm going to show you how to do that. So for our intents and purposes, what we want to do is, again, save everything under programming assignments or programming exercises or programming notes. So the first thing that pops up as soon as we do an Arduino, so this is our editor that we could go off and create our code for it. So by default, it comes up with some, looks like some random name, but it's not really. It's given the date up there. The first thing we want to do is just save this to a particular file. So what it does underneath the covers is that it's actually going to, whatever name that we put up here, it's actually going to create a folder. So let's call this lights. And what we want to do is we want to save in our Google Drive. So go to Classroom and then find your course folder. So for me, it's going to be under different else, but find your course folder and we will save this under Programming Notes. So let's do a save. And notice that up here, the title itself has changed for lights. And every time we pull this up, we're going to have this code. So every new Arduino project that you create, it's going to pull up this default code. So there's actually two sections to Arduino code. One of the first things you might notice since we've been programming in Python all year is that things look a little bit different. And I'll go and highlight some of the differences as we go off and program this. So the first thing we want to do is this inside this code. So this is Arduino uses a language which is very C-like. In fact, it would not surprise me if underneath the covers it is C. But what it uses is these brackets to sort of block off code. So in here, there's these things called functions that all Arduino programs would need, and that's why it starts up this way, giving you these two functions. And the first thing we have is the setup. So setup only runs once. When we first start or load our Arduino and the code gets in there, this code only gets executed once. So we have to do some certain definitions in here. So one of the definitions is we need to set up the pins. So in this case, we're going to say a pin. So which pin that we set up is number 8. And because we want to send a signal to the light to turn on and off, in other words, we're throwing output to it, that's what we're going to specify, that pin 8 is for output. So one of the things that is going to be very different in terms of in Python is putting a semicolon. So that's going to be actually one of the more common errors that you're going to occur when you do programming for the Arduino, is forgetting the semicolon all the time. To me, it's almost like a period at the end of a sentence in English. If you forget that period, it's not going to work. Okay, so the nice thing is that when you do, there's going to be a nice error to tell you about that, and it should be hopefully easy to spot. So that's what we really want to do, is set up the pin and saying that it's number 8 that we want to have is for output. Now inside the loop code, so this is a function loop, and again, all the code that we're interested in is going to be in between those two brackets. And the reason why it's called loop is, so it's a good thing that we took up loops in programming Python, is that once Arduino starts up and running, this code gets repeated over and over and over and over again until we unplug it. So it's to what we call really an infinite loop, but it's an infinite loop on purpose, because if we have this Arduino functioning, it's doing a certain purpose, we actually want to keep this running over and over and over again until we stop and unplug it. So in some ways it's a different programming paradigm that we're sort of used to, that we don't usually want things to run forever. Arduinos in this case, technically we don't want to run forever and ever. In fact, if it's hooked up to a battery, it can never run forever and ever. But in this case, it's going to run until we get no longer power to it. So to send a signal to turn something on, it's actually really easy to do. The command is called digital write. And it takes what we call two arguments. So the first thing is, well, which pin do we want to write to? So in this case, we want to write to right pin. And the command, or you think of it as command, but really the variable for it to turn on is really we want to send a high signal to pin 8. So that's going to tell the Arduino to send a high signal to pin 8, and that should turn our light off. So again, we don't want to forget our semicolon. And then we want to do a digital write. So let's turn this light on and off. Well, actually, let's just turn it on for now, and let's just see if that works. And although it's not interesting, it's going to repeatedly turn this light on. It sounds kind of weird because we only have one line of code in here, but technically that's what's going to happen, is that the controller is going to continuously send a high signal to pin number 8. In other words, continuously turn this light on. Now, what happens in Arduino is that when the light is actually turned on, it will stay on until we actually turn it off. So I'm going to demonstrate that a little bit later on. So I'm going to encourage you to do 2 steps in terms of uploading to Arduino. First of all, even without the Arduino plugged in, we could check if our code works. In other words, does our compiler actually understand the codes, what we call compiling? And that's what this check mark box is for. They call it verify, but to me it's actually compiling the code. So we click that. It actually says down here compiling sketch. And to me, it'd be kind of nice if it says that something was successful. In this case, nothing was said. It actually says done compiling here. We could assume that it works. So let's hook up our Arduino. So here we want to take our USB plug and we want to plug that into the computer. So my iMac has 2 USB ports, so we sort of have to configure it. I'm plugging it into the one that's on the right, and as soon as you plug it in, so we can see that the light bulb here is plugged in. And now what we want to do is, as soon as you plug it in, you can see the lights of the Arduino, the controller come on. So the green light is on, saying that it's on. I'm not 100% what the yellow light means, but it's on. So here we know that the Arduino has power. Now if we try to upload, so in other words, we want to, now that this program's compiled, what it does is there's an actual built-in executable. It's converted our code into zeros and ones. It's going to upload that code, that assembly instructions, onto the Arduino. And so that's what this upload is for. And then first time doing this, you might get this error, okay, saying that it can't open a device. So what you want to do is go up to Tools, okay. So first of all, let's check that your board should say that it's the Uno, because I think all of us bought the Uno board. We want to choose the port, okay. So right now, because it might be the first time, or in this case, I switch ports on mine. You want to check whatever is that says USB modem. Okay, so let's just check that, select that, and let's try that again. And now that we've done this, hopefully your Arduino does what mine has done, and the light is on. Okay, and like I said, underneath the covers is continuously turning that light on. All right, so let's sort of extend this example, and let's say that we want to turn the light on and off. Actually, before I get there, one good thing when we sort of program Arduino, and since we have some experience programming in Python, is making good use of variables. So how can we make this program a little bit more robust? So one of the things that, like I said, we could plug this into pin 8. We could actually move it to different pins. Let's say that I've disconnected this and later on reconnected, and I don't remember what the code says, but you know what? I want the green light and I plug in a certain pin. Well, that pin, next time I could plug pin 9, pin 10, and again, anything from 0 to 13. So in order to make our program more robust, is we want to actually use variables. So in this case, we might say we want to create a constant. So that's the thing that's going to be different in Python is we need to what we call define the type of our variables. In this case, we want it to be an integer. Constant here means that we don't want the value of this variable to change throughout our program. Because here, if we want a certain light to a certain pin, that's not changing around. So we don't want to inadvertently change the value of this variable in the rest of our program. So we define it to be constant int. So in this case, we could say, well, what is pin 8 representing? So in one way, we could say it's a light. We might introduce more lights. In fact, that's the next thing I'm going to do, or I'm going to get you to do, is to put a second set of light in there, a second light bulb in there. And light is not as descriptive anymore. So we can say first light, second light, that all kind of makes sense. But because we actually have something visual and more concrete here, we could actually say that this is a green light. So here, green light. And here I'm going to assign the value 8. So again, we need to remember our semicolon. We should comment our code. So comments in Arduino code or C code, we use the // That's very similar to the pound sign in Python, where it says this starts the comment, and everything after the // will be ignored by the compiler. So here, defining green light, green light to pin number 8. Okay, so now our code becomes a lot more readable throughout the rest, because we're not going to say 8 anymore, but we're going to say green light. We're going to have use output, and then digital write. In other words, we want to turn on or send a signal to the green light to high. So one of the things that is in the language here is that they've defined these high and low variables. To me, it's not very intuitive. Maybe if some people it is, but to me, it's not very intuitive that high actually means on, low actually means off. So what I'm actually going to do is I'm going to be a little bit more tricky, just to make our code a little bit more readable, is I'm going to create some other variables. Here I might say constant on. Well, that's equal to that's the same as high. And I might say constant off, and that's the same as low. So we want to, in this case, turn the light on and off. So after we turn it off, then we say we want to do a digital write. In other words, we want to send another signal, digital write, to the green light. So really underneath the covers, the pin number 8. And in this case, we want to turn it off. And I'll just change that high to on. Okay, so now, first of all, let's compile the code, make sure it works. Just let me show maybe as an example. Let's say I forgot a semicolon somewhere. So let's say that after this digital write on, I forgot the semicolon. So here, excuse me, when I verify it, I'm going to get an error. And it says expected semicolon before the digital write. So it highlights this line, but really the error is above it, saying that it needed a semicolon. Okay, so let's add that in, and let's compile. Another thing I just wanted to highlight that's a bit difference between the language that we're using for Arduino, and from now on I'll just say the C language is different than Python, is that when so in this example, when we have this block of code, notice that it's indented. Now in Python, there's certain parts that we require to indent. In fact, if you indent where you're not supposed to, you actually get an error. In this language, indenting is optional. So we could have all this code to the left and with no indentation, and that's fine. We could indent it as much as we want, and that's fine as well. Okay, so in this case, what we call the white space actually doesn't matter. I strongly encourage you to continue indenting where it makes sense, because indenting is a way to sort of format a code and really make it a lot more readable and a lot easier to sort of read and understand. And that's why I like to use Python as an introduction to programming language, because it sort of forces you to do that already. When you have to indent, when you have an if block or a loop or a while block, it forces you to say, you know what, this code we want to do only if the condition is true, and it forces you to indent it. That's actually a very good programming practice to, no matter what language you use, to continue using on. So anyway, so this code is now compiled. Let's go off and run it. And it's going to upload. And as when I was uploading, actually that yellow light was flashing a lot. Not sure was that yellow light. Doesn't actually say anything. Anyway, so it's flashing a lot. And if you look really close, you can see that light turn on and off super fast. Right? Hopefully yours is turning on off. You can see it. And if you can see it, your eyes are better than mine. Because right now I can't detect when it's coming off. Okay, so again, this loop is repeating over and over again. So this code is going and is not slow. I would estimate that this loop runs about 1,000 times a second. 1,000 times a second. So right now, 1,000 times is turning that light on and off. And in fact, it's doing it so fast that it's not even, the light doesn't even have time to turn off. So how can we emulate this? How can we get a blinking light? Well, there's a notion of what we call a delay. So we could actually get our program to sort of pause a little bit into in between statements. So what we really want to do is, after we turn it on, we actually want to wait a little bit. So in this case, the command to wait is actually delay, and what it takes is milliseconds. So maybe I'll comment the code above. We want to wait half a second. That is 500 milliseconds after we turn the light on before turning it off. Okay, so that right's actually really important. Sorry, that delay is actually really important. And let's go off and let's see if the code compiles. And let's run it. So here, I'm going to try to show you the light as I hit the upload button. So upload, and you can see that the yellow light starts flashing and the code is up there, and now it's running, and ooh. You guys see it blinking? Looks pretty solid to me. So what's going on? Why didn't it turn the light off? And again, in theory, it actually is. So this is a really tricky part, and let's sort of analyze the code. So here, again, it starts the loop. We're turning the light on. Then we're going to wait half a second. Then we turn the light off. And remember what I said, this is really a fundamental concept of Arduino code is it's going to execute the loop again right away. No pausing, not anything. So right after it turns the light off, and that's why the purpose of the brackets, it goes back to the top of the loop, it starts the code again, and what's the first thing that we do? We turn the light on. So we technically turn the light off, but we never saw that opportunity. So really what we want to do is, after we turn it off, is we want to wait another half a second. So let me maybe comment this. After we turn the light off, we need to wait a bit in order to see the light turn off before the code goes back, or not say the code, but the program, let's say, goes back up to the top of the loop, top or the beginning of the loop. And turns the light on again. So really we needed to add that little delay. So let's try that. Another thing kind of nice to know is that every time we build, so you always have to build, even when you upload, it will do a build first before it uploads, but your source file will always be saved then. Okay, so this is again a little bit different than Python, where when you run the program, when you hit the run button, your program actually isn't saved. So we always have to consciously hit Command S to save. Here we don't have to do that. Now let's go up and upload. So I'm just going to show it live. So if you can see it as I upload, the yellow lights will start flashing. The code was uploading. And now we do see it blinking. So now our code actually works. So that's fantastic. Hopefully it's a little bit exciting. Some of the nuances that we kind of see in terms of programming is, that we need to sort of iron out our logic, and then when something isn't going right, and this is sort of the difficult thing about hardware or Arduinos is, it can be either a hardware problem, or something's wrong with the connection, something's wrong with how we connected the components together or our wiring, or our program is wrong. So we know our program was wrong in the first place because the light actually turned on. So we know that connections were actually right. If the light never turned on, then we have to be sort of worrisome. Is it the actual connection? There are times when I've worked in projects in the past when the bulb was actually burnt out, and so it never turned on, and we looked at the code looks good. So in the end, we just sort of switched one bulb out and another one in, and it started working. So there's lots of things to sort of troubleshoot, what we call troubleshooting or debugging, to figure out what might not be correct in terms of our Arduino. Now, another thing I just want to quickly highlight is that we missed another great opportunity for another variable. And what I want to do is, let's say we don't want to wait. So we're here where it's flashing, and it's flashing a little too slow. We actually want to speed this up a little bit. And if we had a variable to start off with, that would have been a lot easier to do, because really we're waiting 500 milliseconds. So we have to go off in here and just change this twice. So here, maybe it's not going to be a constant, but here we just make it an integer. We can say a delay time is 500. So notice that I just forgot to highlight as well. I'm creating these variables outside of these functions. It's what we call global variables. Not the best thing to do, but we'll take care of that in grade 11 when I encourage you not to do that. But in this case, for Arduino, it's kind of a bit necessary for us to do this. So here is we're going to create a variable delay time that says 500. In fact, I want to speed this up. Let's make it 200. And now instead of delaying a specific value 500, we're going to give it a variable delay time, pause time, whatever you want to call it. Okay, you can save the code as you're typing, so Command S still works. But here, let's go off and build this source, make sure I made no typos. Everything works, fantastic. So let me upload that. And we see our Arduino lights flashing, and hopefully you can tell that the green light is actually flashing a little bit faster. In fact, let's play it around a little bit. Let's change that delay time to be maybe 100. And let's try this again. So we can just do a straight upload. And now hopefully you can see the lights flashing a little bit faster. Okay. So go off. There's some challenges that I put in the code, in the Google Doc for you to sort of now hook up two lights. Let's see if you can hook up two lights, green and blue, and see if you can make them turn on and off simultaneously. So the same idea. Let me go back. This is really flashing really fast. Let's change that to be 500. Let's upload that. Okay, so now it's flashing. So idea is maybe hook up a second bulb so it doesn't matter what color it is. Just make it not green so you can actually see the difference. Maybe a blue, my example, but you can use red or yellow. And see if you can make them flash at the same time. The other challenge would be, now if you get that going, is make them alternate. So that's what I call blink. So the green light comes on, the blue light goes off, and then maybe after half a second, the blue light comes on, and the green light goes off, and back and forth, back and forth. So sort of like a police siren in some sense. And then the one last challenge I had in there was sort of changing the delay time. So maybe for 5 times it's going on and off for half a second, and then change it really quick to be maybe 2.2 seconds for 15 times. So for the first challenge, when I say attach a blue light and make them flash at the same time, that's what it should look like. Okay, so for the next challenge or example, I want you to try is to now get the green and blue light alternating back and forth in terms of how they blink. So that's what it should look like. So for the last challenge, where you get the lights going back and forth at different speeds. So it's going to start off slow, and then it's going to go fast, approximately 0.2 seconds in between each time here for about 15 times. Then it's going to go back to slow, again half a second between each for about 5 times, and then going back to fast. So this is a real challenge. It could be done with loops. So if you're interested in how to use loops in Arduino, you could let me know, and that gives them extra help regarding that. While loops still you could do this with a while loop, but even without doing loops, this challenge is achievable. It's just the coding is a little bit tedious, and hopefully you can see from coding without loops that using loops would be extremely advantageous. Anyways, good luck with that, but that's what the last challenge looks like.